Alright, here are a few examples on 7-7, which is adding and subtracting polynomials, also known as combining like terms, and it's something that we've worked with in the past when we were talking about the distributive property. And you may see some distributive property as you work through some of these, but it all follows exactly like I'll show you. So first of all, if you've got a bunch of, so polynomials just means many terms basically, and if you've got terms that are inside parentheses, you do want to be cautious as to the symbols that surround them. So for instance, to the left here, there's nothing on the outside of the parenthesis, and then when I look in between them, there's a plus sign. A plus sign is not going to change the terms on the inside at all, but if it is a minus sign, that is going to change the terms on the inside to their opposites, as I'll show you in the next example. So technically on this one we can kind of ignore the parentheses, but it is always good to be cautious. So the next thing we need to look for then is, with addition and subtraction, we have to have identical variables and they have to be to the same powers. Otherwise they can't be combined. So this is unlike multiplication and division, where you can multiply and divide any two terms that you want to, but you can't necessarily add or subtract all terms together unless they have like terms. So I like to kind of do a circle method and look for anything else that has a u to the fourth, and I find out later on that this does have u to the fourth, so I'm going to take 5u to the fourth plus negative 2u to the fourth to get 3u to the fourth. So it's just addition, basically. Or you could have done 5u to the fourth minus 2u to the fourth. Looking to my next term, I've got a u to the third, v to the third, and I don't see any other of those. So if there's no pairs or anything that matches, we're just going to keep that in our answer. So 2u to the third, v to the third. We'll keep moving along here. A positive 6u, and notice how I'm including the symbol in front of the term because that indicates whether it's positive or negative. And I also see a negative 3u, so I'm going to do 6u minus 3u to get a positive 3u. And then we are left over with a 7v to the third with no pair. So this is technically then the simplified answer here, and usually they're ordered from highest power to lowest power, but technically you could order this however you want to. Alright, so moving on. Here's an example of where we've got two sets of parentheses. The first set of parentheses doesn't mean too much, but the second set does, because that's going to change the values of the stuff inside the parentheses there. So really we've got minus x to the third plus 3x to the second. And we'll look for pairs again. So I don't see any x to the fourths, so that's just going to be in my answer. We'll keep moving on. X to the thirds. I do not see any x to the, oh yes I do. Here's another one. Okay, so we have 2x to the third minus 1x to the third, which is 1x to the third, or just x to the third. It comes out positive, so we put a plus. And then we'll keep moving on. We've got 1x squared plus 3x squared to give me 4x squared. And I believe this would be our simplified answer right here. And that's how we do that. One more example. I just wanted to go over one that has a bunch of different stuff going on. All of these you can see have the same variables, but remember they also have to be the same powers. So this one doesn't have parentheses, and that's okay. But when I look at this, I'm looking for anything else that has a u to the second times v, and I do see that we have that here. So 3u to the second v minus 4u to the second v, or 3 minus 4, I get negative 1 u to the second v. You can put the 1 if you want to, but do not have to. I have a negative 3u to the fourth v to the third, so I want to look for another u to the fourth v to the third, and I do. That's two negatives, so I got negative 3 minus 6, which is a negative 9, so we'll put it in as a minus 9. And then lastly, u to the third v to the second. Looks like everything here had a pair. So 2 minus 1, and we get 1 u to the third v to the second. Should be a v there. So final answer, simplified, would be that right there. So this is 7-7, adding and subtracting polynomials, combining like terms. All right, thanks.